Welcome back, students. Welcome back to the concept success. I am AMK. Today, there is different topics I have taken from class 10 physics. Chapter is electricity, and the topic is potential difference. What is potential difference? Suppose, let us consider, students. Let us consider a conductor. A conductor and 2 points at A and at B. Suppose at point A, here is a charge Q. Here is a charge Q. And the potential at point A is V1 and at point B is V2. Now, I need to do work. I need to do work to carry this charge from point A to point B. Listen carefully. I need to do work to carry this charge Q from point A to B, and that amount of work done with respect to the charge is called potential difference between point A and B. Clear? Suppose the amount of work done is W. W is the amount of work done is W, and I have to carry this charge from point A to B. I need to do work done W. Then potential difference between point A and B is given by V2 minus V1 is equal to work done by charge. Work done by charge. Work done is equal to W and charge is equal to Q. This is the expression. This is the expression for the potential difference between point A and B. This is the expression for the potential difference between points A and B. Students, you can calculate potential difference between 2 points uh, of a conductor by using this expression. Huh? Simply, you need to do work to carry a charge from one point to the another point. That amount of work done is said to be the potential difference between that two particular point of that conductor. Okay. Now, another factor, students, you have to learn. Another factor you have to learn that electric potential, electric electric potential, electric potential. Now, students, what is electric potential? Suppose you have a point charge. You have a point charge Q within an electric field. This point charge suppose said to be within an electric field. Now another point charge Q, positive point charge Q has to bring to close to this charge. You also have to do the work. That is W. Then that amount of work done is said to be the electric potential at this point Q. Okay, clear? When a positive point charge carry from infinite to a point which is within a electric field, you need to do work, and that amount of work That amount of work done is said to be the electric potential at that point of the charge, positive point charge. Okay, electric potential is very important factor, very important term to understand the electric potential difference. I hope clear. I hope you all guys are clear. Okay. Now let us discuss about the SI unit of potential difference. we have we have potential difference V delta V is equal to work done by Q. SI unit of work done is joule and SI unit of charge is coulomb. Coulomb. Joule per coulomb is equal to volt. V-O-L-T. The SI unit of potential difference is students volt. Clear? SI unit of potential difference is volt. That is volt is equal to, you can say volt is equal to joule per coulomb. Okay. Now there will be another question arise here. 1 volt. 1 volt of potential difference. What is 1 volt of potential difference? Now I am going to clear that point also. 1 volt. See students, 1 volt is equal to, suppose here is a point of 1 coulomb charge, and you need to do work by W is equal to 1 joule to carry this charge from this point to this point. That amount of work done, suppose say 1 joule by 1 coulomb, 1 joule per 1 coulomb is equal to 1 volt. It means when 1 coulomb charge is carried from one point to another point, you need to do work done is 1 joule, then the potential difference between that two particular point is said to be 1 volt. Okay, 1 volt is very much important to understand the potential difference. And a question like define 1 volt of potential difference of point A, between point A and B, then you can define like this. Okay, now I am going to discuss with the help of an example. I will take an example from a reference book like Essant related to the potential difference. See, here is a book I have taken of physics from Essant Publishers. Okay, now the question is calculate the work done. I will write this question. I will try to write this question here. Here is the question. Students, calculate the work done in moving a charge a charge of 4 coulomb, a charge of 4 coulombs from a point at 220 volt to another point at 230 volts. Okay, this is the question that I taken from S1 physics S1. Okay, now study the question carefully. Calculate the work done. Suppose it means you have to calculate W, and we have to calculate W here. In moving a charge of 4 coulombs, Q is equal to 4 coulombs from a point 220 volts. Suppose the charge is at 220 volts, and to another point 230 volts. It means when the charge 4 coulombs is at 220 volts, and then we have to bring this charge to another point at potential difference at potential 230 volts, then we need to calculate the work done. Okay, now I am going to solve this question. Given Q is equal to 4 coulomb 4 coulombs, and electric potential is given. Suppose at point A and at point B, electric potential at point A is 230 volt, and at point A is 220 volt, and at point B is 230 volt. What is the electric potential difference? What is the potential difference these 2 points A and B? That is V1 is equal to 220 volt and V2 is equal to 230 volts. Now V2 minus V1 is equal to 230 volts minus 220 volts is equal to 10 volts. Okay. Now V2 minus V1 is equal to W by Q by definition. V2 minus V1 is equal to, we have 10 volts. W by Q is equal to 4 coulomb. That is W is equal to 10 into 4 is equal to 40 joule. Students, we have to do 40 joules work to carry 4 coulomb charge from potential 220 volt to another point at potential 230 volts. This is the amount of work done we need to do. Okay, I hope you will understand these problems and clear your concept about potential difference, and do practice different types of numericals related to the potential difference. Okay, and I will discuss in my next video about Ohm's law, resistivity and resistance, and I will try to clear the concept about that particular topic in my next video. Okay, have a good day.